Welcome back to ArmanisMath. Today we're going to focus on properties of logarithms. Properties of logarithms. And in this section, we are basically going to do some addition and subtraction and some other things like that. Okay. Here's the warm-up for today. I will not going to spend too much time. Just going to put the timer here for you, and please do the warm-up even after you watch the video, even after you attend here with me. Make sure that when you watch the video, spend time and put the timer, please. I've got this couple students asking me they're not doing very well on the test because of the timer. Make sure that that's what you do. Time yourself, even with little stuff like that. So that's going to help you. Anyways, I'm going to put the timer here. I'm not going to wait for too long, but if you, as we always do, at least give me a couple of these here. So once you get number one, show me with the whiteboard, number two, etc., etc. Okay, don't wait until you finish all of them. Okay, I'm gonna pause actually here. So at the 3-minute mark. Okay. Can somebody help me out? 2 to the 6 times 2 to the 8. How much would that give us here? And I'm gonna have my eyes on multiple screens here at the same time, so I can see what you guys are. Here we go. 2 to the 14th. You basically add the powers. This is 2 to the 6 plus 8, which is 2 to the 14th. How about this dude here? 3 to the negative 2, 3 to the 5th. 3 to the 3rd. Negative 2 plus 5, 3 to the 3rd. How about this dude here? 3 to the 12 divided by 3 to the 4th. 3 to the 8th. 3/12 minus 4, or 3/8. And got what this awesome guy here. 4 to the 3rd, 4 to the negative 1. 4, 3 minus what? Minus plus, right? Because it's gonna change its sign, right? Minus plus 1. So basically you're saying it's minus 1. 4 to the 2nd. 3, this is kind of same as, this is a little bit different, but this is 7 to the 3rd. The whole thing is raised to the 5ths. Well, this is 7, 3 times 5, which is 7 to the 15th. Well, these is exponent, properties of exponents, which we do have a dedicated video on that if you still have doubts. Okay, and based on last time's discussion, log, it says write in exponential form. So I'm going to have to go from logarithmic to exponential form. Can somebody help me out? Can somebody help me out here? Somebody's saying... yes, 1 second. Yes, you're right, Haley. This is not right over here. This is a typo. This is a mistake. I have to correct my mistake here. She's right. Let's take a look. I have 4 to the 3rd at the top. Like this. Times, I'm going to move this dude here to the top with its 4 to the 1st. This one's going to go at the top. That's 4 to the 1st, which will give you 4 to the 4th. Good catch. I wasn't That was a mistake I did, and I just fixed it here. Thank you, Haley. Okay, how about down here? Write in an exponential form. Does anybody recall how to write this in exponential form? What's the base here? I see that, Taylor. Good job there. I see x raised to the first gives me the answer, right? X to the first gives me the answer, which is x. How about this dude here? It doesn't matter where you actually have the equal sign. You could just rewrite it log base x of 1 equals 0, right? You could just write. So they just flipped it, thinking that they could trick us here. So how did I start this one? Again, Taylor is giving me the answer. Gamma, where are you guys at? X 0. X to the 0 power. That's going to give you a 1. Okay. Anybody in doubt on these? Please review the last video. Here are some answers for this data. I will be able to use the properties of to simplify logarithmic expressions. Also translate between logarithms in any base. Obviously, we're gonna go all three. There's about 16 examples, and that's why I said the time frame for this class is not allowed for all of them. That's why you need to watch the final product when I publish that. Give me one word from the objective, please. If you're on the live stream or the other sides. Properties. I will translate. Okay. Mth power times base, same base to the nth power will be just adding the powers because they have the same base. Well, in this is called the product property in logarithm. So for example, if I have log of base 3 of 1000, I could break out the 1000 to 10 times 100. In logarithm, you go from multiple times n. So basically, you have to do the first log of whatever the number is, or the variable, m times n. So it's going to be the first log of m times the second log would be the log of I should say plus the second log of n. This one says express log base 6 of 4 plus log base 6 of 9 as a single logarithm. Remember, we could go from addition to multiplication or multiplication to addition. So this is basically going to be something like log. You really have to have the same base to do this kind of trick. Log base 4 times the 9. What is 4 times 9? Does anybody know what is 4 times 9? Which is log 36. Now comes your last class thoughts here and knowledge. This I'm gonna evaluate this here. Okay, log 36. So, and I have a base of 6. What takes you from 6 to 6? This is now you're gonna flip your brain to the exponential side of your brain. So you're gonna say 6 raised to what power will give me 36? That's what you're asking. That's the question. 6 to what power gives you 36? The answer is 2. So the value for this log is just going to be a 2. What we've started with was addition, and we said we have in log we have a property that goes from addition to division to subtract. I'm sorry, from addition to multiplication, from addition to multiplication. Or vice versa, by the way, multiplication to addition, that's fine. I was ahead of myself here, but addition to multiplication or multiplication to addition, and that's what happens in log. So I was able to multiply the items here, 4 times a 9, that gives you 36. And remember, this happens when you have the same base. You've got to have the same base to do this kind of trick. Turns out to be I'm looking for a log base 6 of 36. And I moved my brain to the exponential side to help me figure out what's going on. 6 raised to what power gives me 36, and it turns out to be just a 2. So the value for this whole log is just a 2. Let's do another example. This one says express as a single log and simplify if possible. I've got log base 5 of 625 and log base 5 of 25. There's multiple, there's actually two schools of thoughts here that we could use. Perhaps the first one that comes to mind is simplify it first. Or multiply it. So let's just take the traditional route first. I'm gonna say this is log. It's gonna be a humongous number, so if you have a calculator, you probably want to just tab into that source. Log base 5 of 625 times 25. Somebody get us a humongous number here in calculator. Find us what is this humongous number here. Okay, now I do have some values suggested from your friends. So now I have a log of base 5 of 15,000. Somebody confirm that number, please. 625. Somebody confirm 15,625. And if you do that, you looks like multiple of you are typing at the same time. Okay. I just wanted you to confirm. Was this the number correct? Yes, looks like it's correct. So now you're gonna go in your powers now. 5 raised to what power gives you 15,625? 5 raised to what power gives me 15,625? So obviously it's going to be more than 3, right? Because 3 is going to give you 125. Somebody's saying 6. So you multiply 5 times itself 6 times. That should give you the 6. Okay. If that is true, somebody confirm, please. Somebody's saying 5. Somebody's saying 6. Somebody confirm. It is 6 for Christina and Taylor and Isabella. And we have 6 as a value here. Okay, so the value for this one is 6. There is a shortcut I may use this side to do. So this one, base 5 of 625. How much is... what would take me from 5 to 625? Just by itself, just this portion here. 4? 4. Okay. Well, this means you guys made a mistake. It's not 6. 4. Okay. Now, how much would it be if I go to 25? From 5 to 25. You guys did not make a mistake. I'm just joking. So this was 2. So basically the value for this is 4. The value for this is 2. 4 plus 2 is 6. That's another way for you to do this kind of problem. Okay? 2 different ways here. You don't really have to multiply if you know what you're doing. The value for this here is 4. The value for this here is 2. 4 plus 2 is going to equal to 6. If it's easier for you to do it that way, that's right. They did actually choose to multiply here, but I'm saying there's a shortcut. Okay, let's see another one here. This one says log base 1/3. Can we have fractions as base? Of course, why not? Base of 1/3 of 27 plus log base 1/3 of 19. So basically I am gonna multiply. This one is probably easier to multiply. So I'm gonna say this is a log base of 1/3. Remember, you could do this when you have the same base. Log base 1/3 of 27. Be careful, be neat. Make sure you have it lined up. And so what about 27 divided by 9? How much is that? It's actually 3. So now we're going to think, what's going to take you from 1/3 raised to what power? That's just my exponential mind, which is very useful, by the way. Gives you 3. Third to what power gives you 3? Okay, let's try this. If you actually put 3, that's going to be 3 1/3 times 1/3 times 1/3. That's 1/27. So let's try another one. What takes it from 1/3 to 3? Think about flipping the base. Here we go. Wasdik. Yep, you flip the base. So the actual answer for this dude is -1. So this whole thing is actually -1, believe it or not. A second property says that you could go from division to subtraction, or vice versa, subtraction to division. And they're trying to have you guys think about exponential as well. So for example, if I said b to the m power in exponential divided by b, same base, to the nth power, well, what you do is just subtract the powers because you have the same base, b, m minus n. Well, what happens in the quotient or the division property of logarithm is if you have, for example, log base 5 of 16/2, you could actually make this division a subtraction. Go from division to subtraction. That becomes log base 5 of 16 minus the bottom with the denominator, log base 5 of 2. And that's how you do this kind of problems. You actually could reverse. You could go from subtraction to division or division to subtraction in logarithms. This one says, do understand that as you have, for example, of a to the 5th and times b to the 3rd, you cannot simplify this. Obviously, you have this different bases. Logarithm must have the same base to be simplified. Okay, here we go. This one says subtracting logarithms. Express log base 5 of 100 minus log base 5 of 4 as a single logarithm. I see a subtraction here, and then simplify if possible. Subtraction in logs triggers in my brain division. So I'm gonna say again, I'm just rewrite again, log base 5 of 100 minus, please be neat in your writing. This is not the same as 5 next to the 100. Be very neat in your writing in this chapter. And I know that I could go from here to division. Log base 5 of 100 divided by 4. Well, that's going to give me log base 5. What's 100 divided by 4? 25. 25. Now my brain's asking the same question. You guys remember? Your brain's gonna be switching from exponential to log to exponential a lot of times in this chapter. So basically, you're asking 5 raised to what power gives you 25? And the answer is gonna be 2. That is the answer for this problem. Just a 2. Okay, so once again, from subtraction to division, or vice versa. That's the properties of log. Let's do one more example. Express log base 7 of 49 minus log base 7 of 7 as a single log. Simplify if possible. So this one is log base 7 of 49 minus log base 7 of 7. Somebody tell me, what kind of property would I use here? From subtraction to what? Here we go. I'm going to divide. Log base 7 of 49. Divide that by 7. And how much is that? That's log base 7 of 7. We talked about that last time. What takes you from 7 to 7? 7 raised to what power gives you 7? Yep, exactly. That's going to be the 1. So 7 raised to the first power equals 1, which means the whole value for this dude here is just a 1. There is a sneaky way behind the scene. I mean, you could also do a shortcut here. For example, you could say, well, I could think of this one as its own chunk. So what would take me from 7 to 49? 7 raised to what power gives you 49? Here we go, 7 to the 7. So you could say this is 2, right? The value for this is 2. How about this dude here? From 7 to 7, we just talked about that. That's 1. 2 minus 1 is just a 1. Another sneaky way, shortcut. If you are into shortcuts and you know what you're doing, you also could use that way. Okay. All right, this one says a power property of logarithms. Power property, sometimes called plug. We alluded to this, I believe, also last time, but we're gonna review it again. Let's say this is a log base 10, obviously, right? There's no base, there's a 10. Base 10 of 10 to the third. Well, you kick the 3 outside the log. That becomes 3 log base 10. And obviously, you know what gets you from 10 to 10 is 1. So the property basically states if you have a log of a base b of a to a p power, then you kick the power outside, that becomes log p, the power, times the log of the b base of whatever you have. So you basically kick the log outside, the power outside the log. Let's take a look here. Expressed as a product, simplify if possible. Let's see. This one says simplifying logarithm with exponents. I'm gonna actually split this in half so we can have enough room for each. That would not be over here. Right off the bat, I'm gonna kick the 6 outside the log, so that becomes 6 log of base 2 of 32. My brain is going, okay, gotta think. 2 raised to something here gives me 32. What is that something? 2 raised to an exponent gives me 32. What do you think is that exponent? Multiples are writing 2 to the 4th, because 2 to the second is 2 to the second is 4, to the third is 8, to the fourth is 16. Yeah, here we go to the 5th. So you're thinking about 5. So now think with me a little bit here. You got 5. I have the value for this dude here as 5. This chunk is 5. Well, remember that you have the 6 waiting for you outside here. Like, what about me? What about me? Okay. Just a second. So what is 6 times 5? That is the answer. 30. Yep, that's the answer. Okay, cool. Let's do one more. This one looks huge, but if you again truncate it, if you truncate that value, it becomes easier. So kick this outside. Outkick the 20 outside, so that becomes a 20 times log base 8 of 4. That's a little bit tricky here. How do you go from 8 to 4? That's gonna take you some time to think. So from 8 raised to what power gives you 4? That's interesting. 8 raised to what power gives you 4? Interesting. I cannot put 2, obviously, because that's 8 squared. There's a couple questions. Some says saying 1/2. Can I try 1/2? Like 1/2 means, by the way, square root. Excuse me. So square root of 8 is the 1/2. What's the square root of 8? Well, this is a 4 times 2 here. 4 times 2, which means I have 2 square root of 2. Okay. Interesting. 1/3 cubic. You're getting closer, Coomer. If I put the cubic root of 8, that's actually going to give me a 2. So now how can you go from a 2? Cubic root of 8, by the way, is 1/3, right? So this is a 1/3, basically. You're telling me this is 1/3. 8 to the 1/3, which is cubic root, which is going to give you a 2. Now you need to square the 2 to give you the 4, remember? So you're actually going to do also a 2 times that here, times 2, which becomes 2 over, here we go, cool. 2 over 3, you got it, boy. So you've got, basically you have here, I've got 20 times 20 times the value for this dude here is 3 over 2. 2 over 3, I'm sorry. 2 over 3. Let me choose a different color for that. 2 over 3 times 2 over 3. Well, how much is that? What do you mean, how much is that? I just have to multiply. 20 times 2 is 40 over 3. That's just the answer, 40 over 3. Okay. There's a question here from Jordan. How do you know when to use instead of normal? Tell me more, Jordan, about that question. You're asking how to use this. Looks like I moved on. Was this the A in A? How to use when you put the number in front? Oh, okay. Well, obviously it's the exponent. There's an exponent here. See that? There's a little thing here, an exponent. So I have a base. Basically, you have 3 scripts. You have underscript. You have the script itself. You have superscript. That's why I say be very neat when your guys are writing your homework. So with the superscript, obviously, it's talking about a power, exponent. That's the one that being kicked outside. Yep. And that's why we call it a plug. The power, take that outside, that becomes a plug. Okay, let's do more of this since this looks exciting. We've got a few minutes left here. So let's do more of this here. And I also give myself more room here. Let's do this quick. So I have 10 to the 4th. Can somebody tell me what's the base here in letter A? What's the base? There's no base here. Is there any base here? Stop. What was the base if there is no base? Last time, you guys. If there's no base, there's always 8. Yes, Jordan, a 10. There's a Jordan. There's a 10 here. If there's no base, there's always a 10. So I'm gonna kick the 4 outside. Plug, power to the log. So that becomes a 4 log 10. What's the base again? If there's no base, what's the base? Here we go. Don't forget that. 10. So basically, you don't have to put it. I'm just putting it for you. So 10 to what power gives you 10? That's what you're asking. 10 to what power gives you 10? To 1. So basically, this whole spiel is 1, and you have 4 times the 1, which is just a 4. Okay, how about this dude here? What do you think I'm gonna do? I'm gonna kick. What do you think I'm gonna do? Kick what? Kick the 2 outside. Power to the log. Power plug. Student came up with that acronym, or funny saying plug. So 5 to what power gives you 25? So basically, you have for this spiel, you have a 2, but you still have a 2 waiting for you outside. So 2 times 2 is going to be 4. What if there's a base of 10? What if there's no base of 10 and the same number as the... It has to be a base of 10. You, in our case here, you have to be a base of 10. Okay, let's do this example here. Express as a product, simplify if possible. So let's take a look here. Being multiplied. I would do, George, I would do the first two, so 2 at a time. Because you're multiplying, even like in regular multiplication, you multiply 2 numbers at a time, right? So this one is another example of plug. So I will kick out what? Can somebody help me? What would I kick out here? Got a 5. Give me a second here. I'm going to answer that question. You just give me a second. Let me finish this problem. Base 2 of 1/2. We know what to do now. From 2 to 1/2. What do you think you need to have? 2 raised to what power gives you 1/2? Two raised to what power gives you 1/2? If I put the square of 2, it's not going to be a half. So think about a different one. We talked about this earlier. We got a problem. If I put 1, it's going to give me 2. You're close though, Jordan. Yes, Ali. It is -1. Just flip the base, remember? So the value for this dude is -1. Well, remember, you still have 5 waiting for you outside. What about me? What about me? Well, okay, just wait. 5 times -1 is -5. Focus on the inverse properties of logarithms and exponents. Remember, they are inverse functions of each other, right? Logarithmic and exponential are inverse of each other. So we did discuss this last time, so we're just gonna do a few problems on that. It states if you have log base b of b to the x, you basically kick the x outside, which becomes a log base b of b. So x times log base b of b. And how do you go from b to b? B raised to what power gives you b? Well, you know that the value here is going to be 1, right? So x times 1 is just going to be x. And they have examples here for us, which we're also going to do examples. The other one, the other property, this was this guy here. The other one is here, and this one says if you have a b raised to log of the same base of a number, this is called undo. These guys undo each other, these here, leaving you only with the x. So let's see this in action, okay? We're going to see this in action. So let's simplify each expression. So basically I'm going to refer to the log property, meaning I'm going to put the power outside the log. That becomes 11 log 3 of 3. Can somebody help me out? What is the value here, do you think? What would take me from 3 to 3? And I see multiples are writing in the chat. Good job. So I see 11 times 1, right? So you have a 1 here. But this guy says, wait, what about me? Okay, 11 times 1, which will give you the final answer, which is 11. Let's take a look at this guy here. I've got log 3 of 81. Okay, so I have to think a little bit about this. 3 to 81. How would I break 81 in terms of powers of 3? Powers of 3. Log, base 3, 3 to some power. I see multiple users are typing. 3 to what power gives you 81? To the third or fourth? Are we sure? To the second is going to give me 9, and then to another second is going to give me 9, so to the fourth. To the fourth here. What do you think I'm going to do to the fourth here? What do you think I'm going to do to the 4? I'm going to move it up front of the log. That becomes 4 times this blob things. 4 times my log base 3 of 3. Well, we just discussed this item here. 3 to 3, log base 3 of 3 gives you 1. 4 times 1 is 4. How about this dude here? 5 log base 5 of 10. Well, if you guys remember, we just talked about that right now. Log base 5 of 10. Well, this thing's called, remember the undo operation? So this thing actually is gone, leaving you only with 10 as the answer. Let's do another one here. This says simplify log. What's the base here if there's no base? If there's no base, what would be the base? Good job there. Yes, it is 10. And this one says you have basically a log of 0.9 times log, that's 0.9 by the way, that's down here, 0.9 times log of 10. Well, this is again a 10, hidden 10 here. 10 to 10, what takes me from 10 to 10? 10 raised to what power gives you 10? Well, that's just the 1. So 0.9 times 1, which is just 0.9. Tell me if you're doing good. Tell me if you're doing okay. Give me a thumbs up if we're doing okay here. I see a good. I see a thumbs up. I see another good. Salma. I see Natasha. I see. Okay. Okay. Now, what do you think I'm going to do here? This is 2 raised to log base 2. What? 2 raised to log base 2 of something. What did we call this operation here? Do you guys remember? I see that Amador. Do you guys remember what we call this? The undo. The undo. Because again, we got exponential. You got as an inverse of log, so the undo, and you're gonna be left out with 8x as the value. Another property here, it says the change of base formula. You're able to change your base, and we'll obviously keep this towards the end. And this one goes like this. For example, if you have log base, for example, 4 of 8, you're able to think a little bit. Think about a base that is common between the 4 and the 8. So obviously the 2 is, because the 2 to the second gives you 4, 2 to the third gives you 8, right? So I'm going to think of that base. What if I change things to this new base, which is the 2 in this case? And you're able to do that. If you change the base, you take the top number goes at the numerator. The bottom, the base, is always at the basement. It's base of the basement. Let's take an example of this property. This one says log 32 of 8. How do you evaluate that? Well, instead of just me plugging it into the calculator, which is another option, I would need to do it by changing the base. And I change the base here by finding something, as I said, as a common base between the 32 and the 8. To me, it looks like both of them are what? What do you think is going to be the 32 and 8? A common base between these two guys. Can you think with me a little bit here? What would be my choice? I got a 2. Yes, I'm going to take the 2 actually. Log base 32, 32 of 8. That's going to be log. Remember, this is going to be a fraction, right? With the top being the number at the top here, the answer, and then the bottom is always the bottom. Log, the new base is going to be a 2. And I have 8. And then log of the new base, which is 2. And I have 32. Now comes your exponential side of your brain. 2 to what power gives you 8? Here we go. And 2 to what power gives you 32? Good job there, Nicole. And 5. Guess what? This is it. This is the answer. That's it. You change the base. By the way, you hope that you have a similar base, right? You would hope. If there is no similar base, there's also another way. Obviously, you just have to use a calculator. Yeah, change them to change both of them to base 10, and that's the default for your calculator, by the way. If it's a log by itself, that means there's a 10, right? So you could just punch in the number calculator, which is actually method number 2. This was method number 1, finding different bases, which is easier, by the way, especially if they said do not use calculator. Or method number 2, which is using method number 2 would be using calculator. You just have to punch the numbers in your calculator. Just like that. Log. So you just have to punch in the number calculator, log 8 divided by log 32. And the calculator understands that you're talking about base 10. So basically what they did here is change this one to base 10. Let me write it down for you, just in case you can't see it. What they did here is change that to base 10. They're not going to write 10, obviously, right? Over log of 32. There's a 10. Remember, there's a 10 hidden. Remember what some of you said? 10 hidden here. We don't put that, right? Calculator understands when you just type log, The default is 10, and you just have to deal with some decimal numbers here. Let's do another one. This one says evaluate log base 9 of 27. Can somebody think which one I would choose right now? If I'm changing the base, what do you think the base I'm going to pick? What would the base... Yeah, exactly. I want to do that. So I'm going to say log base 9 of 27 will give me 2 logs. Log, I'm going to say base 3 of 27 divided by log base 3 of 9. And this is also done mentally here. So 3 to 27 is what? 3 raised to what power gives you 27 is what you're asking. To the third. And 3 raised to what power gives you 9. That's it. This actually is your answer. So some of them are actually easy, and especially if they said do not use a calculator. But can you use a calculator? Yes, of course you could. I wouldn't recommend it, especially if they ask for it to be in a fraction form. Usually calculators gives you decimal format. So you also could change that to base 10 and 27 divided by 9. You just have to use a calculator for that one. We're done with that. It's awesome. So now we have this listen quiz towards the end. Obviously, this is part of your assignment. Make sure that you answer this quiz, and also in the assignment when it's done. Please don't just give me the answer. You know by now that I'm not looking for the answer, only the answer. I'm looking for the work as well. Here is the answers. And I'm sharing with you the answers, obviously, right? So don't just give me the answer. You need to show me work. Alright, this should conclude our lesson today. And be blessed wherever you're at.